Serverless computing, I love it, and I'm not alone. Serverless is a way of writing back-end systems that don't need virtual machines or Kubernetes pods or whatever whirring away at all times. If you want to run some code on the back-end, then you just run it. In AWS, the most important tool for serverless computing is AWS Lambda, which is a function-as-a-service implementation from AWS. With Lambda, you just upload a piece of code and you tell it when to run. It's extremely event-driven, so you can run a Lambda function on a schedule or in response to some kind of event in your application. One type of event that happens a lot in web applications is an incoming HTTP request. A client or another service initiates an HTTP request, sends it off to some endpoint, and that triggers an AWS Lambda that produces a result. In AWS, a good way to create those HTTP endpoints is with a service from AWS called API Gateway. API Gateway lets you define API endpoints that are open to the world, and then you can hook various things onto the back of those API endpoints. So if you have an API Gateway that exposes an HTTP endpoint, and then you have an AWS Lambda that gets triggered when that endpoint is hit, then you have all the ingredients for what we call a serverless API. And that is exactly what we're going to be building in this video. I'm going to show you how you can create an API Gateway instance, create an AWS Lambda function, and then link the two together using the AWS CDK. If you don't know what the AWS CDK is, then check out some of the other recent videos on my channel. But for now, I'll assume you know what the CDK is, how it's used, and what you can do with it. So let's get started. I'm going to be using TypeScript for this, but everything in this video you can create using the CDK in any programming language that's supported by the CDK. So that's TypeScript, JavaScript, Python, Java, C#, and Go. All right, let's get started. In a terminal, run cdk init -- TypeScript to create a new AWS CDK application. Then you go through the setup steps for that, and then open that folder up in VS Code. Now, in VS Code, we're going to create, I've got this file here called serverless API.ts, and this will be our serverless API construct. I've got another video explaining how constructs work, but essentially a construct is an object-oriented representation of a resource or some resources on AWS. So I've created this file called serverless API.ts. This is going to be our serverless API construct. We'll just do a couple of imports here from the CDK library. So we'll import the Lambda classes, and we'll import the API Gateway classes. And we're also going to import the construct base type, and that's just in a library called constructs, which is also part of the CDK. Next, we're going to create an interface for the props that are passed in. If you remember, every construct, it's an object that represents a resource or a group of resources on AWS. And when you create an instance of that object, you pass in some props that give you some very high-level configuration. So our serverless API construct, which is going to be a level 3 construct, is going to have a props object that you can pass into it to configure the API Gateway and the Lambda. So I'm going to call this just serverless API props, and there's going to be two methods in here. Lambda function props, what I'm going to do for that is lambda.function props comes from the basic level 1 construct of a Lambda function, but I don't want to pass all of those Lambda function props into my serverless API wrapper. So I'm actually going to use the omit statement in TypeScript to take a couple of those properties out. I'm going to take out runtime and handler. These two are going to be hard-coded inside my construct. So you'll be able to configure everything else about this Lambda function except the runtime and the handler. And again, you can choose whatever you want to be configurable. I just thought this would be a nice way of demonstrating that some things can be hard-coded inside my API Gateway and other things can be passed in. We'll also need another field on our props for the API Gateway, and that's going to be of type API Gateway.REST API props. We're going to be using a REST API. And then we'll create a construct by extending the construct class from AWS CDK. Now, the first thing we need to do is create some fields for the individual API Gateway and the individual Lambda function constructs. So these are the two things that are being wrapped by our serverless API. And then we'll create a constructor here so you can pass in the scope, that's important, an ID, and the props. The props are going to be an instance of this interface that I created at the top here. Great. You always have to call super on a construct. And then we're going to create an instance of the Lambda function. So the Lambda function is just going to be a new lambda.function, and we're going to pass in this and then a name for it. And then, as I said before, we're going to hard code the runtime and the handler. So these are going to be the same for every Lambda function that we create on this API Gateway, but the rest of the props are going to be passed in from the props in here. So I'm using the spread operator here, and we're basically saying I'm hard coding the runtime and the handler, but the props are coming in from the props that are passed into this. Just if you're interested in what this is the name of the file that we're uploading to AWS Lambda, and this is the name of the function inside that file. Cool. We've included the rest of the props. Next thing we need to do is create our API gateway. So we call this.api and then a new instance of API gateway.rest API. Again, pass in this and give it a name. Now this is just a unique name for CloudFormation, API Gateway and Lambda Handler. It doesn't actually create the name of the API Gateway in the API Gateway service. It's just the name of the API Gateway in the CloudFormation template that this is going to build for us. And again, we're going to add some defaults into the API Gateway as well. So we'll give it a name, and we'll just set some deployment options with a dev stage in it as well. So this is a configuration that's being wrapped by our serverless API construct that we can't change. Cool. Again, we'll spread in the rest of the API props. Excellent. The next thing we need to do is create a Lambda integration. Now, a Lambda integration, this is a construct that allows you to link the Lambda function to the API gateway. So I'll create a new instance of that, pass in the Lambda function, and then call api.root.add method. And what we're doing here is we're saying that there's a get endpoint that's going to use this Lambda integration. So this is not going to be on a path, it's just going to be a root get to that API that calls our Lambda function via this integration. Cool. So that's basically our serverless API construct created. You'll be able to create a new instance of this serverless API and pass in some of the properties for the function in the API gateway. But again, some of them will be hard coded for us. And then when we build this and deploy it to AWS, it will create an API gateway, it will create a Lambda function, and it will create an integration between the two. Right, the next thing we need to do is create a stack for this. Every AWS CDK application needs an actual stack, which is essentially a CloudFormation stack. So we're going to use our construct in this stack. We'll just do a couple of imports like before. We'll import the CDK, and we'll also import Lambda just like before. And that's everything imported. That's all we need. Then we're going to import our serverless API construct from Serverless API. So that's this one here. We're exporting this Serverless API class and importing it as Serverless API. Then we can do is create a new app. So new cdk.app. That creates a new CloudFormation stack in the results. And into that, we can create a new stack, which goes inside the app. And we'll call that my serverless stack. And then we'll create a new instance of that serverless API. Now in here, this is where we can configure the props that we wanted to that haven't already been hard coded. So we're going to give it a name, and then we're going to say, I want my Lambda function props to be, here's my code. It's going to be lam.code.from inline. So in this case, I'm just going to type in, I'm actually just going to paste in a bunch of JavaScript. So we'll just say handler async event console.log hello. Obviously, you can package this and you can upload the location of a zip file, or you can take it directly from your CDK code base. But for the simplicity, I'm just going to put the code in line here. And then if there's any other Lambda props we want, for example, memory size, we can put that into there as well. Brilliant. So next thing we need to do is synthesize our CloudFormation template, and we're now done. So this is all we need. This stack.ts, I'll save that, and this serverless API.ts are inside our CDK application template, and then I can create this from the CLI. So if I go over to the CLI, you can see I can just run CDK synth and create that CloudFormation template. And you can actually view the template that's being created by the CDK if you want to. Remember, as fancy as the AWS CDK sounds, it really is just a wrapper around CloudFormation, and that's a good way to think of it really. It's a tool that lets you create CloudFormation templates through code. To deploy this template, we can actually use CloudFormation itself by just deploying the template it creates, but the easiest thing to do is run the command cdk deploy and then let the AWS CDK manage uploading and modifying the CloudFormation stack for us. So that's it. We can extend this by adding more Lambda functions if we wanted to more routes if we like, or we could do things like adding a custom domain to the API gateway. That's all possible with a CDK. So feel free to experiment with this. I'll link the code to this video on my GitHub in the description below. So comment, let me know how you get on. I'll see you in the next video in this series, which should be on your screen right now.